A misrepresentation, question mark.
A misperception.
A misperception. There we go. Can't even get it right. So I want to thank Alex and Declan and the staff at Ohio State for doing the heavy lifting for organizing the conference, even though I get credit for being the co-organizer. And I also want to mention, though, Brenton Rahm, who was involved in the early conception of this, who was a philosopher here at OSU, and who put me in touch with Alex and Declan. So I just thought his name should be mentioned. Railway tracks appear to converge into the distance. Is this appearance a misperception? Typically, observers don't believe that they do converge physically. There is no fear that the wheels of a moving train will be squeezed by the tracks. These statements thus far are consistent with treating the apparent convergence as a case of illusion, like the Mueller-Lyer illusion. One line looks longer than the other, an appearance widely considered to be illusory, yet we are not taken in, and so we don't misperceive in the sense of making a false judgment about the actual length of the lines, or about the actual physical width between the tracks. Here one might say that there is phenomenal misperception of line length, but no judgmental misperception, except maybe for first-timers. Good enough. But I intend to pursue the idea that the appearance of converging train tracks is not a misperception in this phenomenal sense. Construing it as a misperception depends, in my estimation, on a particular task analysis of phenomenal perception, that it aims to present physical scenes in a way that conforms to their mind-independent physical structure. This is a widely held conception. It is the standard conception of veridicality as advanced by authors as disparate as Richard Gregory and James J. Gibson, and it is described in an unfriendly manner as the standard conception of veridicality by Donald Hoffman. I believe that physical content theorists, otherwise known as intentionalists or representationalists, hold to this standard as well, and that naive realists are hard-pressed to avoid it. This conception makes size constancy the standard of veridicality. Accordingly, the tracks shouldn't appear to converge phenomenally. They should be seen as parallel, at least out to some distance. If they do converge phenomenally, that is a misperception. I'm just going to show the tracks so that we have them here. And I realize this is a photograph. I want it to stand in for the experience you would have if you were actually standing on the tracks. And presumably you would do this at a place where the trains aren't frequent, or where you can see the trains coming, or something like that. All right, so I say these other theorists think that if they do converge phenomenally, that's a misperception. So I have a different attitude toward this phenomenal convergence. I see it as the manifestation of a more general attribute of visual spatial perception, the contraction of visual space in the in-depth dimension along egocentric lines of sight or visual directions. Accordingly, the contraction of visual space, as manifest in the phenomenally converging tracks, is not a mistake. I don't believe that it results from inadequate information about distance provided to the perceptual system. Rather, I regard it as a phenomenal accommodation of the decreasing information with distance, an accommodation that presents the tracks in a manner which reveals action-guiding information and is ecologically efficient. Now, you might be scratching your head. What is the difference between a mistake based on poor distance information and a phenomenal result that is adapted to decreasing information? These two descriptions accompany differing task analyses of the function of spatial vision. If one regards the task of spatial vision as that of recovering and phenomenally presenting the mind-independent metric structure of the spatial world, then the phenomenal presentation of converging tracks is an error. I have called this the physical instruments conception of spatial vision, Rainer Mausfeld dubs it the measuring device conception, although with him it's more with respect to color. Spatial vision should present phenomenally the same structure in the tracks as we would determine by measuring the gap between the tracks with a yardstick, to paraphrase the standard of veridical perception offered by Richard Gregory. An alternative task analysis is that spatial vision aims to present relative spatial properties, but without seeking to achieve congruence with metric sizes and distances. Rather, spatial vision presents various spatial properties in a way that is congruent with some physical properties, but presents others so as to preserve proportionality, but not metric values. According to the model I've proposed, egocentric direction is preserved. Connectedness or next-to-ness relations are preserved in bounded surfaces. Size proportions at a distance are preserved. These properties are presented veridically, at least in good cases and without too much impoverishment of information. They are suitable to guide action, but they are found in a phenomenal presentation in which distance is contracted. I've earlier called this general outlook a perceptual systems approach to indicate its affinity with ecological theories. But as we shall see, for size at a distance, it departs from Gibson's actual elaboration of an ecological physics. In the first section, I consider alternative phenomenologies for the train tracks by exploring the implications of a full phenomenal constancy, considering the phenomenal contrast class offered by Gibson and Rock. I explore the implications of full phenomenology. I then consider the phenomenal contrast class offered by Gibson and Rock of a two-dimensional perspective image of the tracks, and then I describe a third alternative between full phenomenal constancy and a two-dimensional image. The second section discusses the notion of organism-environment mutuality in Gibson and offers an interpretation according to which his concept of an ecological physics was not radical enough because he retained metric congruence with mind-independent shapes and sizes as his standard of perceptual success. The third section specifies some geometrical aspects of a contracted visual space of the type I'm endorsing, noting that proportional relations are preserved so as to allow for Gibsonian information pickup from horizon line cuts and from optically textured ground planes. In the fourth section, I'll briefly draw out some implications of this contracted space for the physical content views and for naive realism, while also noting some things that I'm not saying. And I meant to put the little arrow solution up there before so you could see it, but I guess you all know which one it is. All right, so number one is phenomenologies of the tracks. Under normal conditions of observation, with both eyes open and freedom of movement, I perceive train tracks that are running away from me as converging. I trust this phenomenology as something I share with others. I take it to be pervasive and stable, although without denying that I am able to change the experience by taking a special attitude, such as the painter's attitude. But like the Gestalt psychologist and Gibson, but unlike Rock, I treat the painter's attitude, in which my experience may tend toward a perspective projection onto a plane, as a special case. But unlike Gibson, I take the convergence of the tracks as they run away in depth to be a normal perceptual experience. As we shall see, Gibson wanted the normal experience to be of the tracks as parallel, while he also acknowledged that many observers disagree with him. In any case, there are three phenomenologies to consider here. That of full phenomenal constancy, which Gibson and some others assert, that of contraction and phenomenal convergence in depth, which I and some others assert, and the phenomenology of the painter's attitude as yielding a two-dimensional image in linear perspective perpendicular to the line of sight. Gibson discussed the train tracks several times. In 1950, he treated their apparent convergence as a matter of linear perspective, of taking the painter's attitude to produce the visual field, what he called the visual field in that work, an important contribution in his phenomenological descriptions. He also maintained that size constancy is the normal way of experiencing the world visually out to nearly 1/2 mile. Subsequently, in 1966, he wrote concerning standard examples such as a coin seen at a slant or the converging tracks, quote, "I have argued that the coin does not always look elliptical and that the tracks do not always seem to converge. Surely not to the locomotive engineer, exclamation point. But I do not seem to win this argument. For most people say that they do converge, and the results of experiments on shape constancy and size constancy commonly bear them out." So that's from 1966. Gibson often wrote as if the only possible phenomenologies were of full constancy or of what he called the visual field, a perspective projection into a plane perpendicular to the line of sight. If someone speaks of things looking small in the distance, or of a penny looking elliptical when seen at a slant, they are forcing proximal sensations into experience, according to Gibson, either through impoverished viewing conditions or by adopting a special attitude. Gibson acknowledged that if perception did not regularly conform to what he called the objective facts, 1966, of the environment, that would be a problem for his theory, 66 and 79. Problematic examples for him included cases in which, under full Q, or in Gibsonian lingo, full information conditions, there is, quote, incomplete perceptual constancy, end quote, as when the coin is said to look elliptical or railway tracks said to converge phenomenally. In these full Q cases, he suggested that the described result either reflects poor phenomenology or the results of one of these special attitudes like the pictorial attitude. By contrast, Rock held that the two-dimensional perspective representation is found at an early stage of perceptual processing. Hence, for him, taking a pictorial attitude can reveal what is most basic. Gibson, of course, disagreed with Rock on that point, as do I. In any event, Gibson countered what he described as poor phenomenology by saying that, in the case of the penny, it looks like a circle at a slant, so that, unless viewed at an extreme angle, it looks like a circle. I find this response compelling. I agree with this analysis of the case of the coin and other shapes seen nearby. Gibson responded to the claim that things look small in the distance by saying that they don't. And this was an experiment from his 1947 book that this image is from his 1950 book. He cited an experiment with stakes in an open landscape that yielded average responses of full constancy even at a distance of nearly 1/2 mile. If we take this to mean that under ordinary perceptual conditions, there is no phenomenal diminution at distances of 1/4 mile, or of 100 feet, or 20 feet, I'm incredulous. I don't believe it. I am not saying that to an adult observer, things look as if they were diminished in physical size in the distance, nor am I denying that one can alter the experience of size by taking a pictorial attitude. But I am asserting that, in normal perception, without the pictorial attitude, things are diminished phenomenally in the distance. Before I elaborate this alternate phenomenology, please note that I am not simply rejecting Gibson's experimental results as reported in his 1947 book, Motion Picture Testing and Research, and as cited in other works, both 1950 and 79. However, these results were obtained under, quote, objective instructions to, quote, estimate the real height of the stake out there in the field, end quote. Gibson described this as a naive attitude. As he admitted, the conditions of observation also include the powerful cue of horizon line cutting, which would aid the accuracy of objective responses taken under objective instructions. as a point of experimental method, if it were suggested to him that he might ask the subjects to report on the appearance of the stakes in the distance, in which case they might have reported them as being smaller in the distance, he would have found this to be equivalent to asking them to adopt the pictorial attitude. He would have understood apparent instructions to describe the phenomenal or apparent size of the stakes, as directing subjects to report the two-dimensional visual field, what he subsequently called, quote, a perspective appearance of the terrain and the objects, end quote, as contrasted with full constancy results from, quote, naive observers. For him, the two options are full constancy and two-dimensional perspective image. Let's consider the phenomenology of size constancy and things seeming smaller in the distance. Kafka held that the size-distance invariance hypothesis, not his term, covers these cases. The size-distance invariance hypothesis doesn't itself specify what size something will appear to have, but it says that holding visual angle constant, the perceived size of an object directly varies with its perceived distance. And so these are illustrations of size-distance invariance hypothesis. So let's suppose this is the actual object, sets a certain visual angle. The idea is that if distance is underperceived and size will underperceived, and that those are correlated with each other according to this size-distance invariance hypothesis. If an object is perceived as being at its true physical distance, then it should be perceived with its true size. And that would be down here. So if we had a bunch of these trees or poles or anything like that, if they were perceived at their true distances, then they should be perceived with their true size under this. If something is perceived as nearer than it is, it will be phenomenally smaller. So you can see that from the top image. Kafka considered his description of this relation to apply to the phenomenal size and distance. He was not invoking any underlying process in which perceived distance combines with visual angle through a quasi-cognitive process. To emphasize the descriptive rather than explanatory nature of this function, I'm going to call it the size-distance invariance relation. I contend that the perception of railway tracks extending into the distance, or of a long straight hallway in a building, which we can see right out here, offer counter instances to Gibson's phenomenology of full constancy. As noted at the outset, I perceive railway tracks as converging. So let's look at those again. There they are. This convergence is not merely, as Gibson supposes, specified by linear perspective. If it were, I would experience the tracks in a two-dimensional perspective projection, which would mean, for the usual perspective plane perpendicular to the line of sight, that they would appear perpendicular to the ground and would project into a triangle, a rather truncated one, as we can see here on the right. But my experience looking down the tracks, now we're thinking real tracks here, not just this photograph. My experience looking down the tracks is of them receding into the distance, into the third dimension. They converge, but they do so as they extend toward the horizon. And indeed, there is good evidence that, in normal perception, perceived distance falls short of physical distance in a regular manner, yielding phenomenally converging tracks and things looking small in the distance. This evidence includes psychophysical studies in the laboratory, going back to Hillebrand and Blumenfeld around 1900, and observations taken in landscape settings by Galinsky, 51, Wagner, 85, and Erkellens, 2015, with both eyes open and mobile head and eyes. Further, recent developmental studies support a distinction between perceived space, in which objects appear phenomenally smaller in the distance, and learned cognitive responses to such appearances, which sustain judgments that correct for this phenomenal diminution, as has just been discussed by Carl Grenner. In order to understand the regularity of the phenomenal contraction of visual space, consider this diagram from Age Sloman. The drawing shows a rectangular space, say a hallway, with a physically flat floor, FF, running here from the perceiver's feet here at P1, and then there's FF cross. So that's the physically flat floor. Sloman reports that we do not experience the floor as flat in the sense of forming a 90-degree angle with the observer's body or being perpendicular to gravity, but that the floor phenomenally arises. I agree. And if the floor rises while the directions to locations of the physical floor remain the same, that is, while we continue to perceive directions veridically or nearly so, as I think we do under many conditions, then distance must be underperceived. For example, location C appears in the direction given by the line AC, but because it is seen in relation to the floor, it appears at F at the shorter distance AF. So if we're assuming here that the floor is perceived as rising, and if we're thinking that the size, distance, and variance relation still holds, and that direction is perceived accurately, then if the floor rises, then the distance here has to be shorter than it would be to the physical C, and the staff here, G, has to be shorter than it would be if we were perceiving it out here at B. Taking this phenomenally rising ground to occur regularly, then according to the size, distance, and variance relation, objects will appear closer and smaller as physical staff BC appears at phenomenal location GF. The space is contracted in the in-depth dimension along lines of sight. The diagram shows a Euclidean 3D to 3D projection, but as I've said many times previously, I don't assert a Euclidean contraction. It could be a variable non-Euclidean contraction. And of course, I've already allowed that the phenomenal geometry can be altered, for example, by taking the pictorial attitude. And there may be other factors that affect the phenomenal geometry in specific cases. My only requirement is that a contraction is pervasive in normal experience, so that it's normal for us to see the railroad tracks contracting. It's normal in looking down the hallway to see it converging and the floor rising. This contracted space is a third phenomenal alternative, lying between full phenomenal constancy and a 2D perspective image. To see this, consider this further figure. It is a perspective rendering of a hallway. In this image, the angle between the door jamb and the line of sight where wall and floor meet is 36 degrees. So this angle here is 36 degrees, right? Or this angle here, 36 degrees. That's on the surface. It's taking this as a two-dimensional image in the 2D phenomenal alternative. The physical angle, of course, is 90 degrees. That's being represented here by the perspective image. The perceived angle in a 3D hallway. So if we go out in the hallway and I ask you to line up some sticks and stuff with the floor and with the vertical, then from a pilot demonstration and my own measurements, you get between 80 and 85 degrees. So you experience this angle here between the side of the door and the door jamb. It's about 80 to 85 degrees. So right here. So if I have you say, what's a line of stick up with the phenomenal here, I mean, back a little bit, and with the straight up, then you get about 80, 85 degrees, which is consistent with the rising of the floor. These measurements show that the linear perspective contraction and the 3D to 3D contraction posited here are different. They're as different as are 80 and 36. The floor rises phenomenally by a noticeable amount, but it doesn't achieve the phenomenal structure of a linear perspective projection. Thus, this contraction is related to linear perspective. It is in the same geometric family, but it isn't a projection into a two-dimensional plane. This hall space can be modeled diagrammatically. Here we have a top view on a perceiver P, right down here, looking down a hallway. The physical hallway is AEFB, right? That's the physical hallway. The hallway with the floor rising and the walls converging accordingly is shown by the dotted lines. So here's one, here's another. And E now is labeled E5 for E phenomenal. Okay. Two different degrees of contraction are shown here for illustrative purposes. As I've argued elsewhere, how much visual space is contracted is a brute fact about human psychology. Although we will consider some functional grounds for the contraction, optics does not determine the degree of contraction. The contracted space is a mind-dependent or subjective aspect of spatial perception. Accordingly, there is no optical reason why the ground couldn't appear flat and things appear where they are with their true sizes, or in other words, with full phenomenal constancy. Thus, there's no reason why, when we're standing in a real hallway, the floor would not appear to rise. The angle between the door jamb and the floor would be 90 degrees in appearance, and there would be no convergence of the walls. Although segments AC and AE take up different visual angles, let's look here. Here's AC and CE is what I mean here. AC and CE take up different visual angles. If they were perceived at their true physical location, AC and CE would take up the same phenomenal extent. So if you perceive them here, AC here, and CE here, even though you're perceiving them under smaller visual angles, they would, within 3D phenomenal space, have the same phenomenal extent. They would just be running away from you. This is like Gibson's shape at a slant phenomenology, which I applied to the coin above. The same is true of the train tracks. The fact that they converge on the retina does not entail that they must converge phenomenally. If size constancy were perfect, the tracks would appear parallel. In the Sloman diagram, if size constancy were perfect, then staff BC could appear at location BC, where it is over there on the far side. Although full phenomenal constancy is not ruled out, I believe it would, strike us as phenomenally odd. Not only would it mean that the train tracks don't appear to converge, it would also be the case that a building 100 feet away would take up no less phenomenal space than the same building seen 30 feet away. It would also mean that for a field of homogeneously sized pebbles on the ground, they would not diminish phenomenally at 15 feet, 20 feet, or 25 feet. Similarly, floor tiles or these carpet things here would take up the same phenomenal extent, whether a yard in front of us or at 10 yards, and I invite you afterwards to come and look down there at those squares and see what you think. All right, so the second section is contraction a misperception? The phenomenal convergence of the train tracks, or the hallway, is a deviation from the physical structures involved. Is it therefore a misperception? Is it a misperception? The things in dashed lines. In the case of the Mueller-Lyer illusion, we take the difference in line lengths to be a non-veridical and hence illusory perception. It's a case of misperception. But are all deviations from physical reality to be regarded as mistakes in this domain? Take the infamous sheet of white paper in shadow versus coal in sunlight. Let's say they reflect the same amount of light. So if the task of the visual system were to produce a perception of lightness that is congruent with local physically metric properties, they should look the same. But they look different, presumably because the perceptual system is tracking contextual relations, light relative to illumination. Or consider the Gestalt effects on phenomenal organization. Edges appear with figure-ground relations. Edges may be made more salient than adjacent parts of the surface. Similar objects are grouped together by row or column, even though there is no physical connection between them. How would Gibson think of these cases? I think he would be happy with coal and paper. The taking into account of relations between illumination and surface properties gets us closer to the stable properties of the two objects. But I think he would hold the departures from physics in the other cases to be a mistake. This includes the Gestalt effects and the contraction of visual space. One might have expected that Gibson's distinction between ordinary physics and ecological physics would have allowed him to reconsider the task of spatial perception. Perhaps spatial perception should be theorized as providing useful information for guiding action, as opposed to recovering mind-independent sizes and shapes. In the examples above, for instance, visual direction is perceived veridically, but distance is compressed, at least beyond personal space. In the next section, we will consider more closely the spatial information that remains in a contracted visual space. For now, I want to look at Gibson's ecological physics as applied to the task of spatial perception. It is true that Gibson's ecological psychology took into account, quote, ecological facts, such as the scale of the environment in relation to the organism, the placement of the organism in relation to the scene, standing features of illumination and of surfaces, and the relations of an animal to earth as supportive substratum and to media such as water or air. Such factors are part of his important doctrine of organism-environment mutuality, according to which the relevant scale for describing the environment reflects the size of the organism. Gibson believed that such factors make for a, quote, subjective element, by which he did not mean a mind-dependent aspect, but rather the subject's physical relation to the scene, such as the fact that the nose of the observer is constantly present in the field of view as a physically real, quote, subjective element. Organism-environment mutuality, while describing organism and environment in relation to one another, may nonetheless privilege physical measurements and descriptions. According to Gibson, at the relevant scale, the organism responds to and perceives physically objective sizes, shapes, and other properties, spatial layouts, media, and substances. He thus retained the notion that the objective is constituted by ordinary physical properties, so that the sensory systems he wants to investigate are those, quote, by which an organism can take account of its environment and cope with objective facts, end quote, 1966. The standard for normal spatial vision is, quote, the perception of the true layout, end quote, 1966. True here clearly means matching what physical measurement, as with the yardstick and the train tracks, would tell us. This is not only Gibson's conception, but also Richard Gregory's, as noted above. In a definitional discussion of organism-environment mutuality, Gibson does insist that the animal environment differs from the physical environment, 79. But the difference concerns the scale of the animal, while physics, as a discipline, focuses on the scales of atoms and galaxies. Ecological psychology uses millimeters and meters to describe animal relevant environmental properties, which physics as a discipline does not describe. However, by retaining a physically accurate match as the standard of successful size perception, 1979, Gibson did not escape, as he might have, the naive realist preference for a, quote, objective physical world that perception simply reveals, albeit at an organismic scale. Had Gibson extended his organism relative approach to the task of spatial perception, he might have let loose from metric size matches and gone for relational spatial information. See Bill Warren, 2012. Third section is called Spatial Information Under Contraction. Consider this diagram again, showing the relation between visual space and physical space. Many properties of physical space are represented in visual space, even though distance and so size is compressed. So we're assuming here that the visual space is any one of a whole family of these contracted spaces with respect to physical space. So phenomenal direction is congruent with physical direction, or nearly so. This means that if one set out toward phenomenal F, one should expect eventually to arrive at physical F. So phenomenal F would be one of these. You eventually, by going there, arrive at physical F. Next, two-ness relations on surfaces are preserved. If one looks at an apple, the visible portion is phenomenally present as a continuous surface with points interconnected. The order of interconnectedness remains under contraction, the order of interconnectedness. Similarly, ordinal relations along the ground plane are presented in proper order in the contracted space. So if you've got this segment here, which is it? Phenomenal CE, right? So that could be phenomenal CE. If that's taken to be on the ground, so phenomenal CE would be down here somewhere, right? Phenomenal CE. That's taken to be on the ground. Its parts are perceived in the order of their distance. Further, objects retain invariant proportional sizes, even as they contract in phenomenal size. If a portion of phenomenal EF, one of the horizontal bars there, is twice the visible width of another portion in the same physical space, so this is on the same horizontal, then in straightforward cases, it will be twice as wide physically. Indeed, such proportions are preserved in the contraction. So Gibson's horizon invariant ratio, as a source of information for absolute size, remains intact. Similarly, the relevant size information provided by ground texture, the relative size information provided by ground texture occlusion is preserved by way of proportion. So even if the space is contracted, this horizon line relation, as long as it's contracted regularly, the relative relation to ground texture is also preserved even under a relatively regular contracted space. These various proportional relationships then provide information about the spatial layout, even if metric size and distance are compressed. Aspects of visual space, such as smooth surfaces or ordinal relations, are presentations of aspects of physical space in a manner suitable for action guidance. As a subjective feature of human visual spatial perception, the status of this phenomenal contracted space is in some ways similar to that of color on a relationalist conception. In that conception, color experience is regularly related to surface spectral reflectance, but phenomenal color does not represent such physical properties. Rather, it makes surfaces discriminable by presenting them with different phenomenal hues. On this conception, that color perception doesn't yield the physical reflectance is not a mistake or an illusion. It's simply the way the perceptual system responds to surface color in objects. Accordingly, the contracted space, including the converging train tracks, would not be a mistake. The convergence is the visual system's way of presenting spatial structure. It does so via phenomenal contraction. And so I call this contraction a transformation, not a distortion. Finally, I might note that while there is no geometrical or physical requirement for contraction, there may well be psychofunctional reasons for it. If the visual system aimed for full phenomenal constancy, then with increasing distance, it would be faced with presenting like phenomenal units of surface using ever diminishing unit areas of retinal stimulation or ever diminishing solid angles in the optic array, to put it into Gibsonian terms. But the contraction of phenomenal size in proportion to distance systematically reduces the phenomenal grain of surfaces. This proposal contrasts with a common view in vision science that phenomenal under constancy results from misperception due to poor distance information. Herein, under constancy is seen as a systematic accommodation of the fact that metric information falls off with distance. One needn't suppose that the system has achieved optimality in this regard, only that such information efficiency has been a factor in the evolution of phenomenally contracted portions of spatial structure. So the last section is called Implications and Qualifications. From the point of view of the philosophy of perception, the position described here can be classified as an appearance view, allied with Roderick Chisholm. We see things by having them appear to us. It might also be called a critical direct realism, associated with Roy Woodsellers and at times with his son Wilfred. According to critical realism, actually existing material objects are presented to us through their appearances. We directly perceive objects by means of mediating appearances or representations of them, the objects. The physically parallel train tracks are presented as phenomenally converging, but this is simply a fact about how our visual system presents space, as contracted. It is not a case of misperception. This contracted space presents some physical properties, such as direction, in a way that coincides with mind-independent properties. And it transforms some other physical properties, such as size and distance. By the way, this position avoids the dreaded sense data by rendering appearance as phenomenal intentional contents, as opposed to items that literally possess the properties of color and shape. This position is to be contrasted with the two most prominent positions in the philosophy of perception, naive realism and the physical content view, otherwise known as representationalist or intentionalist. A naive realist might accept that when we see things, they appear to us, but they would mean something different by appearance than I do. I view the appearance as a mental content that is produced in the subject, not as the presence of the object in consciousness, so that the object itself provides the content on the naive realist. In the veridical case, a naive realist assimilates any, quote, subjective elements of experience to physical relations, that the object is seen from a point of view. But, I've argued elsewhere, there is no well-defined mind-independent physical property that is the way the shape or size appears from here. The shape or size could appear with full phenomenal constancy, but I contend they do not. It is a subjective fact of human perceptual psychology that the tracks converge. An adherent of a physical content view might agree that appearances are mental states that express representational content. We would disagree on what the content typically is in the visual perception of color and spatial properties, and on how it is subjectively conditioned. On the physical content view, in successful perceptions, the content directly reflects only mind-independent properties of objects. Any, quote, subjective element comes via the physical relations between objects and perceivers. But I claim the contraction of space is not specified by any physical or optical facts. It is a subjectively conditioned mental content that presents the objective spatial layout under an aspect. Accordingly, for the physical content view, the visual system aims at physical veridicality, but fails to achieve that in cases like the tracks. Such a view must treat the phenomenal convergence of the tracks as a misperception. Now to get clear about some things I'm not saying. As I already mentioned, I am not invoking size, distance, and variance as a process model for size or distance perception. I use it as a description of phenomenal experience, which is held to sometimes. Also, I am not assuming that there is one true geometry of visual space, such as a non-Euclidean geometry of constant negative curvature, as was proposed some time back by someone. The diagram I presented shows the contraction of visual space along egocentric directions. In that regard, it is in the general family of perspective projections. But the form of the contraction may vary with distance, with task demand, with the arrangement of objects in the scene, or with intersubjective differences. These are empirical matters, as we say in the trade. I do find solace in the notion of a general contraction from the work of Granrud, and I find some support for the presence of perspective-based contractions in work done by and with Mark Wagner. Now for some questions before dinner.
Okay, why don't you start? Keep your hands up and I'll take a cue.
Gary, with respect to your hypotheses, I'm largely in agreement. With respect to your characterization of Gibson, I think it's way off. Reading Gibson is sort of like reading the literature on visual space. There are lots of contradictions in there. But if I were listing the essence of Gibson, metric veridicality would not be high on the list. It would be that our perceptions are based on information as one. It would be that Gibson is a functionalist, that information provides, is suitable to help control our locomotion. So I don't deny your quotations for Gibson, but I really think you misrepresent him by holding those particular quotations up and not others.
Yeah, so I was surprised too, because I thought, in the 79 book with the ecological optics, he must be getting much more relationalist and all that stuff. But these quotations aren't cherry-picked out of some little obscure places. They're at the very beginning of the 66 book where he's saying what his conception of perceptual success is. They're later in the 66 book when he's talking about perceiving the spatial layout. They're in the 79 book. I read very carefully the organism-environment mutuality. It just had to do with scale and with the idea that there's things like media and ground surfaces and light from above. But it didn't go into any kind of other mutuality. When you look at what he says about color, he's very physicalist about color. I think I didn't mention that here. I think that's another added bit of evidence that as revolutionary and as much to be admired. So I considered myself very fortunate that when I was in college, my perceptual psychology teacher, one year would teach the normal course, the next year he would contract the normal course to 6 weeks and teach Gibson's 66 book. I consider myself in my life to have been changed by that. So I can't respect Gibson more. But this is what I found after careful study. And I didn't just study the 50, 66, 47, 50, 66, and 79 books. I read lots of the other papers. And I just didn't find anything to make me want to say that he would take it back. Now, it could be not that there's contradiction between the spirit of Gibson and the expression of Gibson.
I'm not claiming he didn't say that stuff.
Yeah. No, but you're claiming that it doesn't represent him.
The quotation that you used at the very end, what did he stress? He stressed neighborhood relations. He stressed ordinal relations, right? There wasn't a lot in there about veridical metric relations. Which is where you seem to focus your criticism most intently on him.
Yeah.
Now, I know lots of Gibsonians who would agree with your assessment. I happen to be not one of them. I mean, I don't believe for a second that our perceptions are veridical, yet I still consider myself a Gibsonian.
Well, veridical on this one standard. So the more important point of my paper is not so much the Gibson exposition, but the idea of questioning the standard of veridicality as metric Euclidean flat space.
Agree with that. Yeah. I totally agree with that. And the question is that Gibson's standard? And I would question it.
Well, so we can disagree, or I'll concede to you either way.
So I think I have a question that's a little bit similar in structure, only not about Gibson, but about relationalists or maybe realists and intentionalists.
Yeah.
If I understood you correctly, to be an intentionalist is to be committed to the view, or a naive realist, that once you've specified the way the physical world is and the subject's location in the world, then everything about their perceptual representation has to be settled. It can't in any way depend on further facts about them.
So I take that to be the case about these spatial things, yeah.
Yeah.
I mean, there are other things like the modality. So they say, well, the modality, that's another thing that comes in, whether it's visual or auditory.
So
that's not reducible to those things.
If I really thought that were true of intentionalism, which is a view I take myself to endorse, then I would reject it instantly because it's completely stupid. We don't need complicated arguments here, right? The way we see color and space and everything else depends not only on what the world is like and where we're located in it, but on the kinds of visual apparatus we have and the kinds of process that information from that apparatus produces. And if you hold a philosophical view that denies that, you're screwed.
Now, we did a careful reading of Byrne and Hilbert actually in my class in the fall.
Yeah, Byrne and Hilbert, I don't think that.
Well, let's just say we did a careful read.
We don't say it, and I think being Hilbert, I can say at least Hilbert doesn't.
You could say this is sometimes called conversational repair.
Right. But let me just go on a little. Would it show that it's somehow subjective if rather than representing, say, intensity, amount of acoustic energy, we took the log?
No, I don't.
Well, but why is your case different from that?
Well,
that's one of many possible mathematical transformations. It's not determined by the way the world is and where we are in it.
So I spoke too quickly, actually. Before I came here, I was thinking, what other example am I going to use if they ask for one? And I was going to use the log example. But my opinion's not settled on it, so I don't feel that I completely understand it. So I don't know how to answer the log. The honest response is I don't know how to answer the log. But if you want to say that we've got the coffee cup there, right? And that, well, so since I go with Gibson, no, let's just go with the railroad tracks. So if you want to say that there's some physical fact in the world that specifies the railroad tracks appearing to converge, then I'm going to want to know what the physical fact is in the world that specifies that the railroad tracks could converge in this way. And if you say, well, it's a way in which we process the information, then I'm going to say, yeah, so now your position is mine, that it's subject dependent, because there's no explanation for why the organism should do it that way. So I'm going to stick with the train tracks, because that's mine.
Maybe I'll just follow up. I think maybe part of what we disagree on is what counts as subjective. Because I think there are a lot of facts about, subjective. It doesn't, as it were, depend on what I think or other attitudes. Here's another way to put it: it depends on me in the sense that I might, as it were, have many different types of measuring instruments that are my perceptual system. And what I find out about the world by exercising my perceptual abilities depends on which of these many possible measuring instruments, as it were, my structure instantiates, right?
Yeah.
If that's a subjective fact, then I think that's right, but I don't myself think it's useful to describe that as a subjective fact, because it's going to lump this kind of view in with a bunch of other views to which it's not actually similar in relevant ways. I think I'll stop there.
Well, subjective is used here in the sense in which space and time are subjective for Kant. These can be completely interpersonally agreed relations, right? So that there's no idiosyncratic variation. So that's what I mean by subject dependent or subjective. It also means that you're not just going to find a physical content that can explain why you're having this kind of content. I mean, that's the view, but I know we might disagree.
Kristen?
Yeah. Flat-footed question. Suppose there were a subject who had similar psychological powers to us, slightly different, such that they did perceive railroad tracks not as converging, but as going straight. Would you want to say that that person is misperceiving? Because relative to perceivers, normal perceivers, they're getting things wrong, and yet it seems like they're representing correctly.
So this is another human being, let's say, or is this an alien race?
Sure.
So another human being. Well, so I've allowed that there might be individual differences.
Okay.
And so I don't know if we want to take the majority to be normal in this, set the norm in this normative sense.
Sure.
So in which case it might be, it's like the tetrachromats in color vision maybe, right? So maybe they have a kind of experience that's different from the trichromats. I don't want to say it's wrong. I mean, we say that the dichromatic experience is wrong, but another way to say it is just that it's a different experience. So I don't think I'm committed in saying that perceiving the convergence is normal.
Sure.
So then this would be a case that we'd want to study a lot, right? Because it'd be very strange. We'd want to know, well, how do they solve the grain problem? What do they do? Does the sort of their ability to perceive surface detail fall off in the way I've predicted it should, if they have full phenomenal constancy, so on and so forth. So yeah, I'm not trying to be an essentialist about what the right way to see the world is. I'm trying to characterize what I take to be a pervasive phenomenon. And if people don't have the railroad tracks converging phenomenally, then I want to talk to them.
Yeah.
Because I want to see, is this really an individual difference, or is it a difference in how we're using the vocabulary of appears to converge, or what is it? It used to be a lot of the disagreement I would get with this had to do with the vocabulary of appears to converge. And they wanted it to be, oh, if it appears to converge, it appears to converge in physical reality, and there's no other meaning, there's no other looks meaning that we could have. But that I don't get so much anymore. But yeah, yours is a good question and helps clarify the point.
PJ?
Oh, yeah, so I guess someone who's also a little bit attracted to your potential, but I wanted to stick up for the possibility for treating a lot of these cases as illusory.
Mm-hmm.
And I was thinking that, I mean, there might just be kind of two standards of success. There's sort of success in the biological, teleological, whatever, some kind of proper function type norm of success versus kind of maybe representational success. And oftentimes, I mean, it's not so absurd to think that getting things wrong can help us in a lot of contexts. So, you know, wishful thinking can help. It doesn't help me get things right. It helps me succeed in some other way. So I guess, could one reply to some of these examples by saying that, yes, I agree that this is not a case of the visual system misfiring or doing something wrong, but the normal functioning of the visual system is, in a different sense, to represent non-politically. I guess that's what I would.
Could you repeat just that last phrase?
Yeah, so the idea would be that the normal functioning of the visual system, say, doing what it's supposed to do biologically speaking, is to produce non-veridical representations of the environment, or at least that producing non-veridical representations doesn't mean that it's doing something wrong. Maybe.
Yeah, and so that's holding to the flat Euclidean spatial structure as the norm, and saying it's wrong in respect to that.
Yeah. By one standard, but not by every standard.
Yeah. So I guess my whole thing is to give up that norm with respect to spatial perception. So I don't know what else I can say about that. I mean, we preserve the idea that you can get at objective spatial structures by using the ruler, by learning to estimate well, based on your contracted visual space. I mean, this was an idea that A.A. Blank introduced when he was trying to defend Lüneberg's negative curvature visual space back in the 50s. And sort of Granrud's work a little bit connects with that old A.A. Blank, which is only found in some book by Grunbaum, who talked to A.A. Blank about. But anyway, that's just a detail. So there can be mistakes in my view, I guess. So if you got the visual direction wrong, I think that can be seen as a mistake. But I just don't want to go with the flat Euclidean standard as the standards for specifically sensory spatial vision. It might be the right standard for objective judgments of what are the facts about the world. I think objective judgments, while relying upon sensory perception, aren't just to be read off of sensory perception. That's also a further implication of this particular view.
Alex?
I think I will pass. It is not a kind of question that can be answered in 2 minutes.
Declan?
So this is very interesting, Gary. I wanted to draw you out a little bit on your positive view, the critical direct realism, just to sort of really help me understand how the view fits into a broader taxonomy of positions in the philosophy of perception. So it might be a slightly boring question for psychologists, but these appearances, it's natural to sort of, since you contrast your position with representationalism, what you call the physical content view, it's natural to think these appearances are not themselves representations. But I don't think it's right to treat these appearances as something like Peacock's sensational properties or qualia, some kind of non-representational. I hope I've got that right. But then it seems to me that when you contrast your view with representationalism, the important contrast is with a certain kind of reductive representationalism. I think there's some interaction with David's question here, but you want to contrast yourself with a reductive representationalist who analyzes the content in terms of, for example, causal covariation or some more complex version of that story. So what I wanted to ask is whether certain non-reductive forms of representationalism are closer to your position. So, for example, David Chalmers has a non-reductive representationalist view. He thinks that there can't be a difference in the phenomenal character of experience without a difference in representational properties. But he denies that those representational properties can be reductively analyzed in terms of causal covariation plus those. Or another view might be Susanna Schoenberg's view, which appeals not to what Chalmers calls manners of presentation, but rather to modes of presentation. You talked a bit about presenting under an aspect. So I just wonder, are you happy to think of these appearances as representational properties? It's just that they can't be given a further reductive characterization.
I mean, one way to put this, according to my understanding of the literature, which could be idiosyncratic or not, is that this is like representationalism, except without the constraint that you have to always account for the content as being a representation of some mind-independent physical property in the world. So you accept that there are ways of perceiving the world that aren't the perception of some mind-independent physical property, but nonetheless present the world in useful ways, right? Action-guiding ways. And so, you know, I got my initial exposure to representationalism from Gretzky and Tai, right? And so then I've seen the position develop, and it looks to me like a lot of rearguard action to try to make it plausible. But look, that I could be misunderstanding everybody for all.
So just to really quickly clarify, there are non-reductive representations like Adam Pounce who say, well, color experience purports to represent color properties, it just so happens there aren't any. That's very different from your view, because color experience is not even purporting to represent a mind-independent property.
No, I think color experience does purport to represent. I think color experience phenomenally to us looks like a monadic property. It looks like, and this I think I agree with Susanna, that it, you know, we experience it as just that, you know, the thing's blue, right? To me, though, that doesn't, as it does say for some naive realists who keep promising us a color but never give it to us. That doesn't mean to me that a relational account of color perception is not right. And so then what is it representing? I don't think it's representing the spectral reflectance distribution. I think its representational role is to present different surfaces under different hues so that we can tell them apart, right? So, yeah.
Susanna, was that a follow-up?
This is a very small follow-up, just a clarificatory. So is it, so would it, sorry. This is just a follow-up on one thing you said in response to Declan. I mean, presumably the world is going to, in some way, constitute the accuracy conditions on these contents. So there's going to be some constraint coming from the world on when the appearance properties represented get things right, which you can say
right.
There's quite a bit of
Subject dependence.
Yeah, exactly. Yeah. Is that right?
That's right.
Okay, good.
So, you know, if you got the ordinal relation of the parts of the wall wrong, that's a mistake, right? And it's based in the physics of the wall. But I think that notion of a mistake can still be applied even if space is contracted. So I want to say that space being contracted doesn't then throw off everything else and make it somehow illusory or false because it doesn't match the way the world is, right? So that's the idea. Or, you know, any of those examples, the direction, the ordinal stuff, any of those could be cases where there's illusory or misperception. So I don't get rid of all misperception. I'm just not counting not getting the metric stuff right as a misperception or a distortion. I'm calling a transformation I'm saying actually it might be ecologically advantageous. It might be really weird if within my phenomenal space I give that building way over there the same phenomenal extent as I give this wall here. That might be really weird, right? I think it would be really weird. It might be disadvantageous to do that. So making full, what's that?
Weird.
This is a technical term in philosophy, and so I apologize to the neuroscientists and the psychologists for using this technical term weird without discussing. I think it would be maladaptive. I also think it would be phenomenally odd. So a lot of this first came from actually trying to think about what would it be like to have full phenomenal constancy? Because I haven't seen very many good descriptions of what it would be like to have full phenomenal constancy. And when you start to realize what it would be like that right here, these table things aren't coming in like that, but they're just going straight all the way. And those tiles out there, they don't appear to go like that, but they're just Euclidean flat all the way. I think that would be shocking, and so that this imagined person would be somebody we'd want to study a lot just to find out what it's like for them, right? Because it would be so different from our experience to have full phenomenal constancy. I don't mean like in 2 or 3 yard or 2. Ow.
I'm sorry, I don't know your name.
My name is Robert. Yeah, I guess I wanted to stick up for the representationalist
Okay.
as well. And I mean, one of the weird things about full phenomenal constancy would be that you'd get visual directions all wrong and you couldn't execute eye movements properly.
Why would you get the visual directions wrong if you had full phenomenal constancy?
Well, I mean, if you're perceiving the tracks as proceeding phenomenally parallel into the distance, then you wouldn't be getting their visual directions right. I mean, part of what you're representing is the tracks as parallel, and you're also representing the difference in direction from the eye between the left track and the right track. So you wouldn't be getting that change in visual directions correct.
Well, so I'm assuming that with stereo vision we've got egocentric direction, right? So cyclopean phenomenal space. So this is a diagram of representing physical space and visual space. And if we had full phenomenal constancy, then our visual space would be congruent with ACEFDB, right? So I could have put a little tiny dotted line by there to show this would also be phenomenal. That's to say the same line gives you both physical space and phenomenal space. In that space, directions to these points are still correct. I mean, sometimes people say, oh, if you had full phenomenal space, then you wouldn't see as much because you would squash out some stuff on the sides. And so I get that a lot. And I used to wonder about that myself until I finally really figured out the geometry. You don't. Everything that is under a visual angle is still under a visual angle. All you've done is you've ballooned out this 3D contracted space to make it have equal phenomenal extents for equal unit of physical stuff. And it doesn't leave anything out, and it doesn't get you any misperception of directions, right? So full phenomenal space from that point of view would be full phenomenally constant space from that point of view would be quite okay. I just think it's odd to have the things, 100 feet away take up the same phenomenal extent as the things right around us. It seems like the wrong bet to make in terms of what you want your visual system to account for. And it also requires making up units of phenomenal extent from ever decreasing information. And so I think that's also an important part of the sort of my functional argument for why you would have this contraction in the first place and why it might be beneficial.
So thanks for a great talk. So I think I was tracking one of the themes, and it had to do with compression and contraction of space. And I thought I discerned another one, according to which what we experience are ratios and ordinal properties, spatial properties. And I just I found I had a little trouble putting those together because, I mean, when I think of contraction or compression, I think of one magnitude being mapped onto another one. So, one would wind up on the compression picture with magnitudes, but on the other picture, ratios. I guess, so I'm, part of what I want to say is, help. I'm a little confused. But also, I just have kind of a general prejudice against the ratio view. Ratios, many different pairs of numbers have the same ratio. And it seems to me that if we were perceiving ratios, what we'd be perceiving would be, really indeterminate between, all kinds of particular magnitudes. But my experience isn't indeterminate. It's, there are determinate phenomenal sizes and distances and so on. So, I mean, if you give me a little help understanding your talk, but also, I just have this kind of general worry about ratio theories that
Yeah. Okay, I think I got it. So in the transformation idea in the compression, so this is represented here as a Euclidean version of that. As I say, this doesn't have to be the exact geometry of the way it works, and it doesn't have to be a single geometry as long as there's a ballpark agreement. So your F should appear there if you had full phenomenal constancy, but appears here or something like that. And it may be that depending on the distance, the compression picks up or something like that. And so that's the compression, right? But within that, the proportion of this to this are maintained, right? And because those proportions are maintained at any horizontal cut of this, you get an orderly set of relations. And so then, if this is transformed by 3D to 3D transformation into a thing in which the road still converges, but in the 3 dimensions, you can still preserve the horizon line cut, right? And so, this was an idea that Rock and the 1959 paper, Rock and Ebenholz had this proportional constancy. And Palmer paid a little attention to it, but hasn't had much attention. But I don't see what's wrong with it. Because
maybe I can put it a different
it would
way.
explain the monster in the hallway, right? To put the perspective in, you show the monsters without the perspective, and they seem the same size. You put the hallway in for the two monsters, assume the shepherd thing, right? And then the back one seems big. Well, is that because of just of distance? Well, it's also that if you look at his relation to the stones, the monster's really big in relation to the stones. So anyway, go ahead and tell me what's wrong.
I mean, when one speaks of a magnitude as compressed, I mean, that seems to me just kind of to imply a misrepresentation theory. There's the physical magnitude, and the visual system, kind of squeezes it down, and so the visual system, because it, contracts or compresses, just by virtue of that alone, commits an error.
Yeah.
And so, I mean,
So that's on the physical instrument's conception of the function of spatial perception. So if you have another conception of function of spatial perception, that it's supposed to present all this physical stuff in useful ways that can be action guiding and that can get you going in the right direction, and that allows you to see that there's a continuous stretch of land here that you can walk on. All that stuff is still preserved. It's just that we don't hold it to that standard of flat Euclidean, which, as I say, would be really weird, because then it would mean that all those things over there were just as big as here, phenomenally. And not a misperception, but that might be a maladaptive way to do it.
There's 3 more people in the queue. But it's time to call it. But I need to find out what these guys want me to do.
Wait, let's do one last short one.
Okay, sorry to cut the queue off. Richard, you were next, and I'm sorry to the two people. Not short? Okay, then you were next.
I'll try to make it short. So let's pursue the action guiding. So I agree in Gibson 79. I mean, Gibson's theory is always evolving, right? But Gibson 79, it's still in process. So he's saying contradictory things within Gibson 79. Even in the same paragraph, he's saying contradictory. And the other thing that he's saying in there is the action guiding component, right? So the whole idea of affordances, which is his move to these relational ecological properties, right, that are not physically defined. And so now if you say, okay, so maybe there's another standard of verticality here, which is the ability to guide successful action. And so I think you just said this, but as long as I preserve like the ordinal structure and I have a one-to-one mapping, I can still walk to things, I can close my eyes and walk to a target, even if I get this massive phenomenal compression, or I can reach to a cup at different distances, even though the cup appears squashed at different distances. So long as I've got that point-to-point mapping, everything goes through, right, in terms of action. So if we now start with action as the kind of criterion of verticality, which I think for evolving organisms, that's all there is. You know, how far does that take us toward? It doesn't get us to the determinate perception of an amount of compression, right? It doesn't. I think.
So action guiding becomes a standard of normativity. Of course, full phenomenal constancy could be action guiding, right?
But it doesn't have to be.
But
I mean,
well, I think it could be, but that's not the only way to be action guiding.
That's
So one way to see this is that here you've got this theme of action guiding, which is a more important theme than the ones I was bringing out for Gibson. And then you've got the organism environment mutuality, which he doesn't really work out as far as he should on my reading.
I think that's the affordance that animal mutuality comes in.
Yeah, but the whole 79 is not just about affordances. There are equal number of chapters about things like spatial layout.
Totally right.
So then we've got Bill Warren, who's now showing us what Gibson should have said by giving up this metric stuff in your 2012 paper that I alluded to in my talk, and that reference was in there actually before I knew you were coming and before I saw you and talked to you. So then that would be a way to do it. And you know, I used to try to say what Gibson should have said, and then I would go to conferences with the Gibson, and they say, well, Gibson didn't say that. And yeah, that's right. But you know, you can respect a figure by developing their ideas, and so that's a good thing to do. And I hope that we're developing ideas of all kinds in this conference for these 2 days.
Thank you.
Let me make a quick announcement about dinner.
Hopefully I give you less